Okay, so we're going to come up with some ways to measure our three-dimensional solids. We talked about what is a polyhedron. We talked about what is a prism. We're going to focus on measuring two parts of a prism. And actually, this is going to be familiar to us. So here I have a prism. I've got a hexagon, another hexagon. They appear to be parallel and congruent, all connected by these rectangles. So this would be a hexagonal prism. First thing we're going to take a look at is the area of those lateral faces, all of those rectangles that are connecting those two hexagons. So if you would, just imagine we take like a knife or something and we slice down this edge and this edge. And by the way, edges are where your faces meet. So you have bases, every base is also a face, and then any part where two faces meet, you're going to form like those sharp things. Those are going to be what we call edges. So again, if I was to slice along some edges here and maybe like unfold the top and bottom hexagons and sort of pull this thing out, I would get something that looks like this. So I took that top hexagon, I folded it back, the bottom one, and then I laid out each of those rectangles that used to connect these sides, these sides, these sides, so on and so on and so on. So I've got 1, 2, 3, 4, 5, 6 rectangles. And what we're going to do is focus on the area of those rectangles because those are all the lateral faces. Well, the nice thing about a rectangle from last chapter, we should all remember our rectangle formula. Area equals base times height. And so the height of each rectangle is going to be the same. Each of these rectangles connected part of a hexagon to the other hexagon, and so those are all congruent. So if one of them is H, then all of the other ones are H. I didn't really point that out, but we're going to start with the regular hexagon, but this really works for any kind of prism. Doesn't matter what your bases are. So this will be like a base, and I have a couple of those. And so if I was to focus on the lateral area of this thing, or I should say the area of those lateral faces, looks like I'm going to do base times height 1, 2, 3, 4, 5, 6 times. So the area of those lateral faces would be 6 base times height. Now, another way to think about that is if you look at your base of your prism, which isn't the same as the base of your rectangle, that prism, it looks like I could say, well, 1, 2, 3, 4, 5, 6 bases. That equals the perimeter of the hexagon. And that actually always works for any kind of prism that you're working with. It doesn't have to be a regular hexagon. It could have been an equilateral triangle. It could have been a right triangle. It could have been a trapezoid. So the general form of this thing is we're going to call this lateral area. And again, that's taking into account the area of those lateral faces that connect your bases. For any prism, is going to be perimeter times height, where capital P equals perimeter of base. And by base, I mean the base of my prism. So this right here, I'm going to say L equals pH. So whenever you're asked a question, find the lateral area of this solid, really what they're asking for, we're going to stick with prisms today, is what is the total area of the rectangles that connect your bases. That's always going to come out to be perimeter times height. Now, they might also ask for the total surface area. The only difference there is total surface area, you're going to include the areas of your bases. So I'm going to use T for total. You could use any one you want. I think your book might use S for like surface area. The total surface area of any prism is going to be your lateral plus the areas of your bases. So I'm going to say 2 times capital B, where P is the perimeter of your base and capital B equals the area of base. Now that's going to change. Your base could be a triangle, your base could be a trapezoid, your base could be all kinds of shapes. Here, that capital B, you're going to have to remember all those formulas from chapter 11. You might have 1/2 parentheses B1 plus B2 close parentheses H if it's a trapezoid. You might have 1/2 perimeter times apothem if it's a regular polygon. So this capital B is something that you're going to have to remember how to find from chapter 11. So these are the two takeaways from what it is that we're going to be doing today. You're going to be finding lateral area. You just need perimeter, the prism base times the prism's height, and that's the distance between bases. And then total area, you're going to take that same value and add 2 of the areas of your bases.